Hi, everyone, and welcome to today's webinar organized by JetBrains. I'm Paul Everett, PyCharm Developer Advocate, and I'll be your host. The topic for today's webinar is Virtualenv, a deep dive. Today we have Bernat Gabor, one of the hardest working people in Python. Python has a lot of hardworking people, so when I say this is one of the hardest, that really means something. He's the maintainer of Virtualenv, a maintainer of Tox, and contributor to many other packages. Part of the wonderful Python team at Bloomberg, who I should note has been a very good friend indeed to Python. Welcome, Bernat.
Yeah. Hi, everyone. So just sharing my screen.
Got it.
That should
looks
be
good.
working now.
Yep, looks good.
Yeah. Virtual environment. Everyone knows the basics of Virtualenv. Virtual environment is basically just a simple tool that allows you to have a Python environment on which you can muck around without breaking your system Python environment. So what I mean by that, let me just have like a simple example. I just create a virtual environment called venv. Okay, I have two options. Once I created a virtual environment, I can invoke it directly by, as you say, typing out the full path, or we have these things which you can use to actually, or we have this other thing called activators, which you can use to improve this without having to type out the entire path. So if I type bin activate fish, you see that my Python now, if I print out the path to it, just to showcase it. Oh. Yeah, just need to type it correctly. Should be actually this virtual environment Python, if my activator script would have worked, but my bad because I don't call it correctly. So if I call source, I have now activated my virtual environment. As you can see, even the shell prompt changed to contain the name of the Python environment. Now, if I type this in, you can see that the virtual environment is actually right there where I created it. And now when I type in Python, I actually mean the virtual environment Python and not the system Python. And why is this good? Well, because, for example, you can install additional packages. For example, I can install Black, and I don't have to change my system Python. And I also don't break my system Python by adding packages that don't work with it. So like in this case, for example, if I type in now pip list, you can see that, hey, now I have Black and all these dependencies on this virtual environment Python. So that's kind of like the basic one. And as I told beforehand, you can either use the activation script to basically hijack your shell to always refer to when you type in Python or pip to the virtual environment Python, or if I deactivate this virtual environment, you will see that you can also carve and use virtual environment without actually activating it. You just need to actually type in the full path. So like pip list, you see this, the output of this is exactly as the output of that. So they're equivalent. The activator script is basically just a small syntactic sugar convenience tool that allows you to not have to type as long paths. That's their whole scope. But so this is virtual environments in a shell, and you might have noticed that I type in this case, Virtualenv to create virtual environments. But for those who knows, there's also this tool called venv in the standard library, which basically does the same. And I can invoke it in this fashion. And in this case, you can see that venv2 is basically also a virtual environment, perfectly work. So the question may arise, what's the difference between the Virtualenv and the venv? And the answer to that is that Virtualenv is a third-party Python project, is something that lives under GitHub PyPy Virtualenv, like right here. And this is all the logic and code what makes Virtualenv Virtualenv. While the venv project is something that's part of the standard library. So if you just Google venv Python, you'll see that what comes up is a standard library tool. And this already shows you one of the main differences. If you want to use Virtualenv, you need to install a third-party package. And you can install this basically by using ppax. That's at least my recommended way. So you can see in this case it's already used or installed for me case. But another way you can, but in case of the standard library one, you don't have to install anything. It's just already available. It just works out of the box. So the reason for this is that Virtualenv, the project as a whole, was actually created back in 2007, while the venv package, as you can see in this help, if we find it, is something that was added to Python 3.4. Okay, and that was basically like 4 or 5 years ago, I want to say. So the venv is much newer, is a newer project, but the Virtualenv is something that existed for 14 years. And the reason for this is that initially Virtualenv started out, the concept of virtual environments started out as a third-party project. Is something that let's add it on the top of the Python. But as soon as it becomes popular enough, the project basically started to come up with the questions, why don't we just include this in the basic Python? As you know, the Python is the language that comes with batteries included. So it's very good to be able to, hey, don't have to install a package. Whenever I just install Python, I already have the ability to create virtual environments. Okay, so that's one of the main differences. And that kind of like put in the short term the Virtualenv project and kind of like a lifeline. Everyone thought that, hey, once we got to the point where we deprecate Python 2.7 and the minimum Python support is 3.4, we no longer need virtual environments. But actually, in practice, this is not true. And this time I'll take some questions, if any of the questions came up, and I'll continue my story from there on the topic of why actually Virtualenv went to a major rewrite this year, and why do we still need Virtualenv, given that we already have a virtual environment creation tool within the standard library now. Paul, any questions?
We have some good questions. I'm trying to think of the order, which ones might be better later on in the conversation. For example, virtual environments in PyCharm. Let's save that one until a little bit later. Someone asked, what is fish? And I think that's a good opportunity to talk about what is fish, but also what it means to write command line tools that need to expose some of their options in shells.
Okay, so the state of the world is that we as a developer person, I say, in university and all that, historically has most been using this shell, at least on the Unix operating system, which is called bash. Okay, I can type in bash, and here in the bash, as you can see, I can have like ls comments and all that. I can invoke these comments, and here, the shell that actually allows me to interact with the operating system and execute the commands is the bash executor, the bash program, the bash command. But obviously, bash historically mostly only worked on Linux. And it's developed, as you can see here, we already are at version 5.0. So it's more and more features added. And as soon as we start developing something, there are going to be other alternative tools to it. For example, another alternative tool to bash is fish. Okay, it's another shell. It's the same as bash, but instead it's fish. But the difference is that you do things differently in it. For example, one of the differences between shell and fish, just to showcase it, is that I can do to print something, a comment, I can do by using this $! sign. And actually in fish, I don't have to type the $ sign to print out the return value of the comment. As you can see, shells different between others. And there are quite a few shells out there in the public used by people. One of them is the most popular, probably is fish, but on the Windows, you might be more familiar with the command/batch executor shell environment, or the PowerShell one, or on the Linux, you have the fish, or we even have a shell which is was written in Python and aimed to be able to use the Python syntax, which is called Sonos. And so, yeah. And this kind of like goes into the question which I talked earlier about it. You know how I say that you have to use this activator to activate your shell? You can see in this case, I have a fish-specific activator. And as you'll see in the later on, we go more into details. Virtualenv actually contains activators for multiple shells. We contain an activator for bash, for batch, for PowerShell, and the list keeps going on. Next question, Paul.
I was going to use this as a chance to ask about there's some really interesting stuff going on with integration with shells going on in Python in the last 6 months or a year. But that's enough of that topic. Let's go on to a couple of other things. Comment from the beginning, that looked really cumbersome to get into the virtual environment. I'm a big fan of the Virtualenv wrapper project because of easy activation. Is there a similar function in Virtualenv?
Virtualenv activator. There's nothing built in per se. You're supposed to invoke the activation script by using the source command, and you have to type it out. But yeah, I think
Okay.
nothing built in, but the Virtualenv wrapper project kind of provides that feature if you want it.
That makes sense. It's a good separation. 2 questions where you get to say as much or as little as you want. Difference between Python virtual environments and Conda environments and Conda isolation.
Okay, I think the Python ones are aimed mostly at the concept of Python will only deal with your Python dependencies and not care about the operating system dependencies.
Good point.
Conda is aimed to basically provide the functionality that it can abstract not just your Python dependencies, but also your operating system dependencies. So when you talk about the Conda environment, it's much heavier than a Python environment, a Python virtual environment, because it doesn't just shell you from the Python specific parts, it also provides a shell against operating system specific stuff. Think about binary dependencies, that kind of stuff. So this also goes with already the differences. If you're creating a Conda environment, it's a bit slower because it needs to do more, but provides more. If you only want a Python virtual environment, you're free to use just the venv or the Virtualenv. It provides less, but it's faster because it provides less.
We get a lot of people in data science, and Conda is very attracted to them because of what you said. So much of the surface area for Python data science is on the C side, and that stuff is highly advanced, depends on a bunch of libraries that might be changing a lot. And so that's a good solution for them there, right?
Yes, exactly. And that's also the reason I think Conda is so popular across data scientist people. Because generally data science people are kind of like in a worse situation because they need to install dependencies that are more complicated to install.
Mm-hmm.
So they basically need a heavier weight tool to hide away all that complexities, which otherwise would require advanced knowledge to set up everything and get going.
I'm going to do 2 more questions, then let you get back. But these are all kind of set. These questions are good because they're setting the scene. Similar to Conda, there's a question from John about, is pipenv a good alternative? And answer the question not in terms of package management, in terms of isolation, and maybe also discuss about poetry as these other ideas for isolation.
Okay, so my answer to that is neither pipenv or poetry are virtual environment tools. They have different goals in it. pipenv is a great tool if you want to develop an application, and that's what you care about, developing an application. Similarly, poetry is great if you want to develop a library because it's very unified interface how to develop and how to maintain a library. But you see it's a different target audience. One is aimed for the application writers, and when I say application writers, think about people who write website backends, that kind of stuff, and libraries are stuff that you want to share across your project. And both of those projects, both poetry and Virtualenv, or poetry and pipenv underneath to achieve the isolation, actually use venv or Virtualenv respectively.
Okay, then the last one, you mentioned pipex, which I'm someone who straddles the line between web development and Node.js and NPM and NPX and the world of Python. So I love pipex and nobody ever talks about it. Could you give a quick explanation?
So yeah, I'm also part maintainer of the pipex package. So
Of course you are.
so yeah, anyway, the solution pipex try to solve is that Python is a great language. Everyone loves working with Python. So we start creating these tools in Python, but they're not actually, the fact that they're written in Python is just implementation detail. But the fact of the day is that in Python, it's very easy to have, it's like a global installation path, and you can install anything, and the packages can have different dependency maps. So it's very easy to get into a stage where installing Black might break ISO, or installing your favorite changelog manager tool might break another tool just because they have different dependencies. So in order to avoid this, how we solve this problem is that each of these tools need to have their own virtual environment and installed into that virtual environment so that when they have conflicting dependencies, they work in parallel. Now, you could do this manually, but creating a virtual environment for every tool and then exposing it to your operating system, that tool, is a lot of work. And this is what basically pipex tries to ease. Pipex itself will create these virtual environments, will install these Python tools into those virtual environments, and will, much more than that, it also provides tools to keep them up to date. We can basically type in pipex upgrade all, and pipex will happily go and, hey, upgrade all, and here pipex will go out and, hey, upgrade all these Python tools for me. So if you have tools that you're using that are written in Python, and you want a tool to install them and maintain them easily, and not have to deal with the issue that they have differing dependencies in each other, then pip is the tool you want to check out.
Okay, I already have a bunch more questions, but I'll save them for the next batch. Let's get back to your presentation.
Okay, so my next topic I wanted to touch on is basically why did we decided to do a rewrite of Virtualenv? Well, the fact of the thing is that venv, as great as it may be, it's actually not that great for usage of other tools. And I already enlisted a few tools that are using venv or Virtualenv, and such tools are Tux,
Sounds like we've lost his audio again temporarily.
Am I back?
Yep, you're back.
Okay, just give me a second because my screen goes.
I'm sorry that GoToWebinar is doing this to you.
Yeah, no worries. It's probably also something on my fault, and so it's a bit probably my fault too. So maybe probably doesn't like my MacBook or something. So yeah, going back to the question. So why did we decide to rewrite Virtualenv? The reason why we decided to rewrite Virtualenv was because as great as venv is, and it's already part of the standard library, its interface for tools, it's not the great. And such tools will be pipex, Tux, Poetry, pipenv. All these tools use Virtualenv. And if you want to create a virtual environment and interact with the Virtualenv package itself, it doesn't provide you enough information to be able to easily use it. Also, venv itself, it's not perfect. It's not done yet. Remember how I say that we're all in this together and we can improve it step by step? I already, just looking at the venv code, I identified that there are some parts that could be improved, and improving these parts would actually make Virtualenv run much faster. And Virtualenv also provides a much better interface for tools than venv does. So being a Tux maintainer, I decided the best way to improve Tux is actually improve Virtualenv. So that's why I started to improve Virtualenv. And once I started to muck around with its code base, I decided, you know what, this actually is very hard to maintain. We need a better structure. And part of this creating this better structure was that, hey, actually we need to just start from scratch, take all that we learned in the last 13 years and write everything from scratch. And this is what I did, probably starting from last June all the way to this February, and released it. And then we had been quite a few bug fixes afterwards, but let's say around mid-July this year, we arrived at the stable stage. Now Virtualenv works very nicely. And what more now, Virtualenv with the new 20-point series, it actually creates a virtual environment that's equal to what the venv package does. So the two tools are now at feature parity as far as, or environment parity as far as how the environments look and behave. And what more than, as a few goodies to convince people to use it, Virtualenv is much faster than venv. And let me put a quick demonstration of that. So this is how much it takes to create a virtual environment. As you can see, it basically takes what was like 250, 440 milliseconds. And if I do the same thing, now it'll be very nice because I use Python 3.9 and I create that one. Wait. Yeah, I actually need to type the command correctly for this to work. So if I use the venv package, you can see that this takes much longer. It took almost 3 seconds to create a virtual environment. So if you're thinking about why should I use venv or Virtualenv, you should use Virtualenv if you want something faster. And one day this performance improvement might make it back to venv, but as of we stand today, venv or Virtualenv as a whole is much faster than the venv project. So this is kind of like showcases that we can improve what we already have. And in the meantime, until venv itself gets faster, we can focus on just using Virtualenv, which does the same thing, just faster. And Virtualenv also serves as kind of like a testing ground. We can add features to the Virtualenv, and if people like it and use it, then we can basically also add them to the venv package. And this way, both the venv and the Virtualenv project can flourish alongside each other. There needs to be no anonymity between each other. If you want to have a faster, better experience, use Virtualenv, but mind you, you have to install it and maintain it. If you just want something that works out of the box, even though it's slower, then go with the venv package. You'll be just as fine with it. So yeah, I'll take that also the time to get a few questions.
Okay, good. First one is it's the Virtualenv maintainer that's available. I'm going to ask them a support question. It's about brew.
Yes.
I break my virtual environments when I do a brew upgrade of Python. So for those that don't know what we're talking about, Brew, Homebrew is a package management system for Mac OS, kind of similar to systems on Linux. Any suggestion on how to keep multiple versions of Python around for different projects on a Mac?
I personally use PyEnv for the same reason, because I want, as you see, if I use PyEnv versions, I have this many Python versions installed, all in parallel, and I use PyEnv to maintain things. That being said, and upgrading Brew should not break your virtual environment. If it does, I mean, we don't have to support it, but I would like to support it. If it does break, support the bug request and we can have a look at it. The way Virtualenv is written, and I'm not talking about venv, just Virtualenv, it actually should fall back to the newer version and work as if it would have been created the new version, pending some caveats. So yeah, that's my answer to that question.
Next, I have two, maybe related a little. I have two virtual environments which have different Python interpreters. Is there a way that we can use one Virtualenv and switch the interpreter without deactivating? I think I know the answer, but I'll let you do it.
Actually did not understand the question, so I'll defer it.
I think this is really a Tox question. If you've got a project that needs to do two versions of Python, or for other reasons needs to have two Python interpreters, what's a good way within a virtual environment-based project to switch interpreters? No, actually, they're asking without deactivating.
Without deactivating? Well, my answer to that is that whenever I have multiple ones, I don't generally tend to use the activator. I just use the direct paths, as I showed you here, like the venv BMP list, and this is going to work independent of what the activation is set up. But it should be also possible to nest the activating. Like in theory, you could activate one of them, and that would activate the new environment, even if you're in another one. So then you would be able to like kind of like deactivate retroactively and activate going deeper and deeper. But yeah, I think the
And
fastest and the
I'm
least headache.
sometimes associated with the Pyramid project, and long ago they made the decision to document the hard way to type everything because of this issue.
Yeah, I think it's also a part of it. If you see lately, on most of the tutorials, we prefer to type like that when we want people to say something explicitly, because now we know that they're going to run with Python 3.8. Because if you just type in documents Python -m, people expect to work with any Python, and Python actually can point to any of these magic versions up here. So, and obviously sometimes you do want a given version. So whenever you need specific and you want that specific version, it's always helpful to just type out fully.
Indeed, and as a warning to all of you out there in Python land, you're going to see a lot more people typing in their tutorials and things Python -m even for things like running pip to update pip. The console message you get tells you to run pip not directly, but through Python -m for some of these reasons.
Yeah, it's the same reason as here we say, like in my case, I have all these Pythons active in the same time. If I just type in pip, I literally could be referring to any of the pips of this. And it's very nuanced which one would actually be picked up. So if you do care that, hey, I want to install something in exactly this, just type out fully and then you will not have issues with it.
Okay, now this next one is clickbait, bike shedding, whatever you want to say. Virtualenv, venv, pipenv, conda, pipx, lots of overlap there. Any discussions among all these projects to converge on a standard tool or some other ways to share? The Zen of Python, there should only be one way to do it.
Okay, so as I said beforehand, even for end users, it might seem they have a lot of overlap. In practice, they don't, because as I said, all these projects use Virtualenv or VM for their actually managing virtual environments, but each of them add additional capability on top of them. For example, Poetry is very friendly if you want to develop libraries. pipenv is very friendly if you want to develop applications. pipx is very friendly if you want to maintain and install packages. Now, there has been a discussion to create kind of like a global tool, which is, I think people from other languages might be more familiar. For example, in Rust world, cargo is everything. So yeah, this is something that actually would require people interested to contribute from within the community to basically create this magical tool that pulls together all these specific tools that do one thing very well, but don't do everything in the world of Python package management and development, and pull it into one single tool and give it one unified API. Now, Poetry tries to do this partially. So it's kind of like a solution that tries to give you, but it doesn't have to be just Poetry. But if you want something like that, go check out Poetry, contribute to Poetry. Or if you want something that goes beyond the scope of Poetry, maybe you want to handle even more cases, then reach out to I'm not sure if anyone knows it, but there is the discuss.python.org. And this forum actually has a packaging group. So if you go to the packaging group, if you have any ideas how you want to improve the land of the Python and packaging, post the topic here, and most of the packaging people follow this topic, and we'll also provide you pointers where we think we need to have more development, more help, how we could actually make all this better.
I'm spending a lot of time on questions, and usually I'll get yelled at by the audience if I spend too much time on questions, but this is such a rare opportunity. We have someone who is the core developer of a really important piece of machinery that has a lot of story behind it. So we'll talk a little bit more than we usually will. And I'll use this as a chance to do a public service for you with Virtualenv, for the PyPA people, for pip. All of you out there in the world of Python, this stuff is so insanely hard. Virtual environments, packaging, these were added after Python went out the door as an afterthought. And still, they're like 2 decades old. There are obscure edge cases from the 90s that someone will complain about if you break. And so it's like if you go to the Poetry issue tracker and look at some of the things that are open, they're just so obscure. So I'm sure when you did your rewrite, you probably came across an endless list of weird stuff.
Yeah, most definitely. I think generally in packaging, the hardest thing about packaging is not actually the problem itself. If you think about how things should work, they're fairly trivial in a sense that if you want to just to make it work on your machine, most of these things you may be able to do it in a day. But the problem becomes what might work on your machine often ends up not working on this machine that is 6 years old or even more. When people think about Python, we think there's one Python and that one Python is shipped to everyone in the world. This is a big lie, and it's a really big problem for Virtualenv because actually every operating system packages, oftentimes in multiple ways, Python and ships that Python. And when they package the Python as developed by the core C developer team, they actually do patches and changes to it, often maybe to improve their adhere to the operating system standards or to improve some experience for the operating system users. But all these small changes end up breaking the tool itself. And therefore, if we take a look at the CPython code or the Virtualenv code, and the Virtualenv code for creating virtual environments, and I'll zip in here, you see like this is basically all the logic. How do you create a virtual environment? And you might see that we have a CPython, we have a PyPy module, we have a Python 2 module. So, and all this logic, all these codes actually contain a lot of edge cases and handling various operating system and various Python versions differently. And this is what's really hard to make things work not just for your operating system, for your Python, to make this work for all Pythons and all operating system. And this is probably what takes up 75% of any packaging development.
Looking at that dunder expected site packages thing just makes me very happy that you're doing this for us. Okay, that's enough questions for now. We have 3 more questions for the next batch, but I'll let you get back to the presentation.
Okay, so the next kind of topic I want to think in that when people, it's during the when I decided that hey, I'm going to rewrite this tool. The first thing I did is I need to look at the tool and break it out in smaller portions. Because if you check out the legacy branch, which is the old Virtualenv code base, and I go into this Virtualenv Py, this is the entire logic for Virtualenv. And if I go to the end of it, you can see it's 270 files. And if I go to something like this version info, you can see there's a lot of random error messages in it at various random points or if else's. So you can see that maintaining such forest of if else's is very hard. So that's why what we decided, hey, I actually don't want to maintain a file with 3,000 lines. I want something easier, something that kind of like orchestrates and organizes each various features of virtual environment creation, the subsections, so I can actually wrap my head around it and think of it and be able to abstract each component separately so I can test them separately. Because one of the problems with it was that even testing was hard because there was no way to test just one part of it. You had to test the entire world. So the CI took like half an hour just to run for one environment. And we have to run basically like 40 environments we're targeting. So running 40 environments where each of them takes 1 hour, even doing the smallest change and pushing it in takes ages to actually get the feedback that what you did not break the entire work and it works. So the first thing I had to do is basically find the various subparts of the virtual environment creation. And here are the subparts, which I kind of like broke it down. And if you check out the CLI help message of the Virtualenv, there will be also grouped around these features I call a Virtualenv. The Virtualenv basically 3+1 main features. One of them, its main feature is the ability to create a virtual environment, okay? And this is just exactly creating a Python version, a Python interpreter that resembles the system Python interpreter, but doesn't actually, it's not the same. It's kind of like a virtual environment itself. Then we talk about the seeders. A virtual environment is great on its own, but it doesn't allow you to add new packages to it because without the seeders, you don't have those seed packages that you need to install packages. For example, when you create a virtual environment, let me just showcase that. So I can actually create a virtual environment like this, okay? And this will create me a virtual environment that if I check out the VM folder has literally nothing in it. It has its own side packages, has Python in it, but doesn't have any tools attached to it. And sometimes this is what you need. If you really just care about the Python environment that has nothing installed in it, this is enough. But often when we use virtual environment, we want to install additional packages. And how we install packages? By using pip. So we need to have pip in this virtual environment. So this goes to the question, how do I install a pip within a virtual environment I just created? I can't use pip itself because pip is not present yet. So we need other mechanisms to do it. And this is where the seeders come in. The seeders takes a virtual environment, which doesn't contain any packages installed in it, like here, and adds seed packages to it. And the seed packages we're talking about is pip, setup tools, and wheels. Okay, so these seed packages. So if I remove, for example, from this creation, this without pip thing, and I run it, you'll see that now even the output changed, and it says that, hey, I actually added these seed packages, pip, setup tools, and wheels. These versions are now available. So if I go to now venv bin pip, it actually is there, and I can use pip now to install additional packages. So these are the seeders. And we have two seeders. One of the seeders is the pip seeder, and this is kind of like cheating. It uses pip itself, injects pip onto the Python path, uses pip itself to install these packages. And then we have the update seeder. And this is where much of the performance improvement comes against the venv, because this app data says that, hey, actually, I'm going to cache as much as possible of creating this seed package so that when I actually have to create a new PyCharm virtual environment, adding the seed packages is basically, hey, I take the files and I copy it into the folder. And in case of the pip, it is much more complicated because the pip package has to basically take a wheel or a source distribution and has to inject it, extract it, validate it, all that kind of stuff, which slow down the entire operation. And this is the seeders. Another thing that many people are used to it, and it's kind of like a separate feature, is the activators. The activators are this kind of like extra shell scripts, which basically mangle your shell script environment to inject the pip and Python onto the path itself. So you can call pip and pip list as you would have actually created it. So in this case, if I source activate fish, it's not working. What did I do wrong? Okay. Probably missing something. Anyway, so, oh, I know why it doesn't work. This is the activators. And as you see here, I specify the activators to be empty. That's why I don't have the activators. But if I, for example, add here that, hey, I want a fish activator to be created, now it even printed out, hey, I do have the fish activator, created it. And now if I go to this, I have the activator there. I can use this activator and enter to that virtual environment. So when I type pip list, it actually works as I would have typed out the full path into the environment. And if you check our help, you can see, let me do a Virtualenv. There's this help. You can see that we support quite a few activators out of the box. If you check the activator one here, you'll see that this is Bash, C Shell, Fish, PowerShell, Python, Sonos, all these are created by default. But you can opt for only some of them and have even less file in your virtual environment if you want. And so these are the three main features of virtual environments. And the fourth feature is basically Python discovery. And this is something Virtualenv specific, meaning that if you have installed Virtualenv, you can create any Python version that you have installed globally. For example, if I want Python 2, look, I created a virtual environment in Python 2. If I want the Python 3.10, look, I created a virtual environment in Python 3.10. So I have the ability to specify what type of virtual environment I want. And Virtualenv is smart enough to go out and check and validate where I have those virtual environments from. And actually discover global install system side packages and be able to give you this flexibility to to create virtual environments on demand. Okay, so these are the four main pillars or feature sets of Virtualenv, and each of these feature sets then can be reasoned and developed separately and validated separately. This allows that now CI, if you check for our project, doesn't take an hour to run, but instead, if I go up to this, just to check something lately, for example, in Ubuntu, it takes, I would guess, 3.5, 4 minutes. This speeds up development, speeds up generally just the joy you get when actually need to add changes to this project and develop it. Okay, so I'll take some questions now, Paul.
Okay, and just from a time perspective, we're obviously getting close to an hour, but we'll say that we'll go an extra 10 or 15 minutes to make sure you get to everything. Can you share some thoughts about the architectural decisions when redesigning Virtualenv? You talked a little bit about it. Is there anything else you want to cover?
I think the part that I haven't talked about it is that besides what we keep, it's just as important what we don't want to keep. And some of these, kind of like the things that, for example, the old Virtualenv supported and the new doesn't, is this feature called relocatable virtual environments. And the reason why we did not want to support it is because we had a lot of issues with it, and it's a problem that can be easily solved for all platforms. It's something that can be solved for one platform in specific. So instead of what we trying to solve it for everyone, what we decided with Virtualenv is that now it actually has a lot of plugin functionality. So for example, you can add your own Python discovery logic. You can add your own creator. Like if you want to support Rust Python or Grail Python or a new Python version, you can actually add it as a plugin. You don't have to wait for the core to support it. And that might be specific to only support it for your one platform. Or for example, similarly, you can create even better seed mechanisms. For example, if you want to install these seed packages from a database, perfectly possible. Similarly, you can add your own, if you have a new shell, which we don't cover yet, you can have you can actually add that functionality via plugin. Or so basically, instead of trying to cater to everyone, we went into the design decision, hey, we're not going to support all these things because we can't manage to do it in a scalable way, but instead will allow you to write these small plugins and inject this functionality yourself on your
Did you have to make any decisions about throwing out old versions of interpreters or even alternative interpreters like Jython or anything?
Yes, we did have to do some of that. And that's, again, increases generally how the core can develop. For example, historically, maintaining a Jython integration has been very painful for the sole reason that running the test suite on a Jython takes an hour, because our use case is very bad for Jython. It doesn't really work with just-in-time compilation speedups. So that speeded up development as a whole and also allowed us to new functionalities and new features as a whole, because now we could use tools that introduced in Python 2.7 or 3.4 and later to basically achieve a lot of the things that was in that 3,000 lines I showed earlier in fewer lines, and oftentimes in a more scalable and better maintainable way.
Okay, two more, and then we'll continue. We'll make these questions, the answers, as quick as we can. First one's about virtual environments in PyCharm. I'll cover part of it. We use the built-in venv module in Python 3 when you're doing a Python 3 package. We do use Virtualenv when you're creating a Python 2 package, but we're using an old version. And one of the reasons is we actually have to bundle the software. And so we're really careful about changes and keeping up to date and adding dependencies and stuff like that. Bernat, I know you use PyCharm. Do you have any comments you want to add about virtual environments in PyCharm?
I personally, I like it. I think the only major thing which I kind of like, for example, you can see I also use Tux, and Tux creates a lot of virtual environments, which I can sometimes use. For example, if I'm adding some feature and it breaks on Python 3.4 or 3.9 or anything, I can just easily set that as, hey, I want now my project to use that. And I use this plugin called PyVenv, which allows me to just right click and set, hey, I actually want to use this and then I can pull up the test that's actually failing, and yeah, and just simply run it. So yeah,
Yeah, we have
I'm
a
happy
couple of
with that
questions.
feature.
One of them I'll save until the next batch, but this one's kind of relevant to this. Does Virtualenv support putting environments outside of projects and leaving behind some kind of markers for people who like to centrally manage their interpreters?
I don't entirely follow what is the marker files. Virtualenv doesn't have a global repository of marker or virtual environments or markers.
Yeah, right.
That's something that is offered by Virtualenv wrapper and all these kind of tools.
Okay.
It's something that basically we don't think it's at this moment the core feature of Virtualenv. So we encourage people to use it through other tools.
Good answer. And those tools are actually look pretty active recently with things to go update all of your interpreters or update this package and all of your interpreters and stuff like that. So let me let you get back to your presentation, and then we'll do one more set of questions at the end.
Yeah. Okay, so another nasty feature, which I would like to just quickly go over it, is you don't actually have to install Virtualenv to use Virtualenv. And if you go to GitHub PyPy get Virtualenv, this is another new feature we added with the latest rewrite, is the ability basically to have zipapps, okay? So if I can also write the documentation, but basically it means that if I just download this package from here, and let me not cheat here, actually go to demo. If I go to demo, if I do like, okay, and I download this thing, that doesn't work actually. Oh, wait, I actually have to type in the version, or I can just leave it like that. Yeah. I think I need to specify it. I see my curl is not too good, but if I just download this PyZip package, this is kind of like a zip file that contains everything within it. I could actually just do, hey, give me a Python interpreter, and this package can work on its own. So if you're inside an environment where you can't install a package and you want to create a virtual environment, you still have the option. You just need to have some HTTPS access to download this package, and this will download your virtual environment, which behaves exactly the same as it would be if you had installed it. This is also a great way to bootstrap your operating system virtual environments, because you no longer have to install anything within your global Python. For example, how do I install PPX? Could be the question, because in order to install PPX, you need a Python virtual environment, or you install it in your global side packages. You don't have to. You can just download this virtualenv.pyz and use it to create a VM. And as you can see, it works basically the same way and does the same thing. And yeah, this is a great thing if you want to create virtual environments from within. And you can easily download them from that link, which I presented here, like Bootstrap PyPy or Virtualenv PyZ. And this is guaranteed to have the same version as the latest version released on PyPy. So yeah, I think that's mostly what I would like to cover. So I'll take the rest of the time to take some questions.
Okay, and I will say that zip app thing is pretty mind-blowing. I'm sitting here trying to understand what I just saw, and I really need to think about it a little bit more.
Yeah, that's actually interesting. I think, for example, in this case, just to go for it a more technically challenging, it was a bit challenging how to make this zip app work for all platforms. Because remember, the zip app can be downloaded by anyone just as much on Windows and Linux and various Python versions. And the dependencies of some of these projects differ per operating system. So we actually had to add some kind of logic to dynamically import the correct versions of packages for within. Because if I do like an unzip of this virtual, let me just.
But it's not really like Py2.exe or some of those others, because it's really not trying to. In fact, it doesn't cover C extensions, right?
It doesn't cover C extensions, and that's, yeah. Zipapps are great if you don't need C extensions. If you need C extensions, you need something else. The problem with the other ones like Pew and all that things is that they're not cross-platform. But for Virtualenv, we wanted something cross-platform, and we could take the fact that we're not going to need C extensions. And
I
okay.
saw something come out yesterday, FEET, F-E-E-T, which is
I
intended
haven't
to be
heard
a
about it.
precompiled Python binary that you drop into any of your projects, and it will then discover all of your packages. But instead of having to do py-to-exe and freeze everything into an executable, it becomes like the universal executable. It's really interesting.
Interesting.
Okay, back to the questions. Here should be an easy one. Does Virtualenv wrapper really wrap the new Virtualenv?
It does.
It does. Okay, great.
I think the way it works, it just picks whatever virtual environment it installs it alongside it. So it's possible to wrap the old one. It's possible to wrap the new one. You might need different versions, though, mind you, but as far as I'm aware, it definitely does.
Okay, and last question. This is an opportunity for you to say whatever the hell you want to. It's perfectly open-ended. Docker. There's two parts to this, one which is specific to Virtualenv, one which is a larger question. For Docker containers, is it considered good practice to still use Virtualenv when running the app, or just use the system interpreter that comes with the Docker image?
I mean, depends on what you're optimizing for. Is it absolutely horrible and should never be done to use the system one? Probably not. I don't take that stance. Would it be beneficial to use the Virtualenv one? Sometimes if your users are able to get a hold of that Docker image and they might not have root access to it for various reasons, then you definitely want to have, I think it goes alongside the Zen of Python. Your users should have one way of doing things. And you should pick, either it's going to be always install it into the system package, or it's always create a virtual environment. As long as you create one unified workflow for them, I think it's just a matter of semantics, what you're optimizing for. Having a system, enforcing users to create a virtual environment allows you, for example, to not give entire access to the user over the image. Maybe you have some secret files or something like that in there, and you don't want to give read-write access to all the files. In that case, using the Virtualenv gets you out of the jail. Maybe not. That depends on the use case. But maybe if you don't do that, maybe you just really doesn't matter. Then maybe it simplifies if you don't have a Virtualenv within your Docker image. I mean, there's only so many.
The second part, and the questioner, Michael Klatt, says, this is clickbaity. Maybe we should all just use Docker containers.
Yes. The problem with Docker is, as much as I love it, and I do use it sometimes, is that it's still not free. Like spinning up a Docker image, it takes a lot of memory and also some CPU out of me. Like oftentimes I check my Docker daemon and I see it has 4 gigabytes of memory use, and I'm like, okay, I'm literally running one Docker image. I'm not sure why it needs 4 gigabytes. And also the other thing is, tools are just generally much more better interacted if you use the native one. And PyCharm has some great integration with Docker, but I find even that oftentimes if I want to debug into something, I want to change something, it's just much easier to do it if it's on the disk and not within the Docker image, because modifying files within a Docker image is non-trivial. And sometimes you have to do it, you have to debug it. For example, if there's a breakage or some issue within the standard library, or have your code interact with the standard library, sometimes putting that print statement into the standard library, it's very helpful. And that's something that you do easily if it's a Docker image, but you can do it if it's a virtual environment on your disk. So,
okay,
yeah.
That was a great answer. It sounds like my answer without the clickbaity response to the clickbaity question, which is to trash Docker or something like that. I think that's a good framing of when you should use one versus the other. We'll go ahead and start to wrap up. Before I do, Bernat, do you have anything that, before I switch off your screen, any other things to cover?
The only other thing I would like to say is, like, if you're out of people there and running into issues, don't be discouraged. The packaging ecosystem as a whole oftentimes is very helpful and open for contributions. So opening an issue already helps a lot. If you have a bit of free cycles and you can ping pong a bit with the maintainers to come up with a solution and provide a pull request, that's even better. But we all want these tools to work as best for everyone. So if you have some breakages, issues, feature requests, don't be shy in going to either the issue trackers or the discuss page, the Python discuss page, and create a topic. We all would like to know how we can do better and brainstorm together to find better solutions to the problems we're all facing on a day-to-day basis.
Well said, and I'll switch the screen back to me and kind of remind everybody, if you take Bernat up on his offer and approach these projects, especially these ones like Virtualenv or pip or something, please lead with thank you for everything you're doing before you start to issue a complaint or something, because these projects are so hard and they spend so much time over so many years, and 95% of the time isn't on anything fun. It's on janitorial work for someone else's needs, not their own. And they deserve a lot of praise, a lot of credit, a lot of patience. Participate, but participate with a little bit of humility and kindness. Okay, so thanks, Bernat, for taking the time to talk with us about Virtualenv, the project, and the rewrite. I loved this webinar. I had 100 questions I would have asked. If any of you have any questions later, please don't hesitate to reach out to us by email or by social media. If you'd like to get more information on PyCharm, please go to our website at jetbrains.com/PyCharm. We'd love your feedback on this webinar, so please feel free to contact us on Twitter or in the after webinar survey. We read that thing. Please fill it in. Give us some suggestions and some feedback. The recording will be made available on our YouTube channel soon, as well as our blog and our Twitter. If you haven't already, please check out the blog. There you can find up-to-date PyCharm news about releases and events. Hey, 2020.3 is going to have some cool stuff in this release cycle, so keep an eye on our blog. You'll also find educational resources. So for example, the recording of this webinar will be published there in a few days. We'll also provide some additional links and information from the presentation on the blog. That's all from us for today. Thank you, Bernat. Thank you all of you for staying a little bit later, and hope you have a nice day.
Thank you very much for having me.